Hello, and welcome to this presentation, Getting Started with the CMA180 Power Measurements. In this presentation, we'll explain how to make basic RF power measurements using the Rohde Schwarz CMA180 radio test set. The CMA180 power measurement function calculates and displays the received RF power level and provides functionality similar to that of an external RF power sensor. Note that external sensors are also supported on the CMA180, and this is covered in a separate presentation. The integrated power measurement feature provides measurements of both current RF power as well as various statistical measurements, and this function is supported in the analog TX, DX, and expert scenarios. Power measurements are started by going to the global toolbar and then selecting either the TX, DX, or expert scenario under the analog tab. Power configuration and results are accessed via the Power tab. Note that there's also a Sensor tab, and this function is used to measure power with an external power sensor. It's important not to confuse these two tabs. Please see the separate presentation, Getting Started with the CMA180 Sensor Measurements, to learn more about this other type of power measurement. The device intertest can be connected to either the RF COM or the RF in connectors on the front of the CMA. This is selected in the RF Settings tab. Note that these two connectors have different maximum input power levels, 100 watts continuous and up to 150 watts maximum on RF COM, but only plus 20 dBm or 100 milliwatts on RF in. An external attenuation value, either from an attenuator or due to cable loss, can also be specified. Note that this RF connection is the only one required for power measurements, although other types of connections can also be made. For example, an audio connection to supply an AF signal to the device intertest audio input. Let's now look at the Power Measurement tab. The buttons on the right side are used to start, stop, and pause the measurements. At the top of the screen are the most important measurement parameters, and below these are the power measurement results. In the remainder of this presentation, we'll go through both of these areas and explain how they're used when measuring power. Let's start with basic configuration parameters. Frequency is the center frequency of the signal to be measured, and expected power should be set slightly higher than the maximum expected input power. An external attenuation value can be provided to account for any external attenuators or cable loss between the device intertest and the RF input. Note that a negative attenuation value will be interpreted as external gain when displaying measurement results. The power measurement results are displayed in two different ways. First, the current RMS power, as well as current minimum and current maximum, are displayed. Current means that these values are being calculated over the user-defined measurement length, something we'll come back to shortly. The CMA180 also displays the average RMS, minimum, maximum, and standard deviation since the measurement was started. The parameter statistics count is used to define the number or count of measurements that are used in calculating these statistical values. In many cases, power measurements are made continuously, that is, in so-called free-run mode, but they may also be triggered or started in several different ways. These settings are accessed via the trigger icon in the main GUI. The most common way of triggering a measurement is by a change in signal amplitude, for example, starting the power measurement when the amplitude crosses a defined level or threshold. Triggering can also be done via an external trigger-in signal or via a remote command. Another important trigger parameter is mode, which defines if the measurement runs continuously after a trigger event, or if only a single measurement sweep is performed with each trigger. Signals are filtered before power is measured, and the filter dialog is used to configure the filter settings. The CMA180 power application uses one of two filters. These are Gaussian and bandpass. Each filter has a user-configurable 3 dB bandwidth. The main difference between these two filter types is that the bandpass filter is more rectangular, with steeper edges and a wider, flatter passband compared to a Gaussian filter. This can be helpful in some measurement scenarios, but bandpass filters also require longer settling times, which increases the overall measurement duration. Note that frequency is used to define the center frequency of the filter, and this is the same as the value configured in the main Power Settings tab. The configuration icon provides access to measurement settings, some of which are not available from the main GUI. There are two tabs, one for measurement control and another for RF settings. Of particular interest are the repetition parameters, which allow measurements to be made continuously or as a single shot. It's also possible to configure coupling of these repetition settings between measurement tabs. Another important parameter is measurement length. Recall that the current power measurement results that we discussed a few slides ago were calculated based on this measurement length. The time between measurement intervals is defined via the step length parameter. Let's end with a brief summary. The Power tab in the Rohde Schwarz CMA180 radio test set can be used to make RF power measurements without requiring external power sensors, although external power sensors are also supported on the CMA. Results are displayed in both real-time and statistically as average, minimum, maximum, and standard deviation. The measurement time and statistics intervals are both user configurable. Although power measurements are often made continuously or in free-run mode, these measurements can also be enabled or triggered by waveform parameters or external events. And finally, note that the measurement filter type, Gaussian or bandpass, and filter parameters can be adjusted for improved measurement accuracy. This concludes our presentation, getting started with the CMA180 power measurements. If you'd like to learn more about power measurements, other radio test measurements, or related test and measurement instruments from Rohde & Schwarz, please see the links in the video description.
Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.